Did Mars ever host any form of life? NASA's Mars exploration program has been working methodically to discover the answer to this question for many years. The NASA rovers Spirit and Opportunity discovered evidence that there was once liquid water on the planet's surface. Following up on that finding, the Curiosity rover sent by NASA found that the conditions on Mars approximately 4 billion years ago may have supported life similar to what we know today. Now, Perseverance, the latest of NASA's rovers, will do an intensive look for evidence of Mars's previous life and solve the dilemma of aliens once and for all. But before we move on to aliens, let's look at Perseverance first. The project was initiated on the 30th of July 2020 in the middle of the additional difficulty posed by the worldwide COVID-19 pandemic. It is anticipated that the mission will cost $2.7 billion, and if you think that is way too much money or our tax money to be spent on space, wait until you hear the rover specs. The Perseverance Mars Rover weighs 1 ton, has 6 wheels, and is the size of a subcompact vehicle. And because it is built on the same chassis as the nuclear-powered Curiosity rover, the Perseverance rover can function normally even during dust storms, which prevent the spacecraft from receiving the sunlight it needs to function. When it came time to touch down, the Perseverance improved upon the difficult 7-minute landing phase that was infamously known as the 7 minutes of terror. To successfully touch down, the Perseverance utilized a supersonic parachute, a thruster-powered fall, and nylon lines to drop itself the remaining few meters to the ground. The Jezero crater, around 45 kilometers in length and 28 miles in width, is where the rover came to rest on February 18, 2021. Inside the crater, there is an old fan-shaped feature known as the delta. This feature originated approximately 3.5 billion years ago when a lake and a river on Mars converged. Perseverance is researching the sedimentary rocks formed in the delta due to settling particles of varying sizes in formerly aquatic environment. The rover found an igneous rock on its first research mission when it explored the crater's floor. Igneous rock is a type of rock that can form either deep below from magma or at the surface due to volcanic activity. The delta, with its diverse sedimentary rocks, contrasts beautifully with the igneous rocks found. This juxtaposition offers a comprehensive understanding of the geological history of the location after the crater formed. The major discoveries in this regard were sandstone, containing grains and rock fragments formed significantly far from Jezero crater, and a mudstone containing fascinating organic compounds. The name Wildcat Ridge was given to a prominent rock approximately 1 meter or 3 feet wide. It probably came into being billions of years ago when mud and fine sand settled in a saltwater lake and dried up. A portion of the surface of Wildcat Ridge was rubbed away by the rover on July 20th. Because of this, it could investigate the location using a cutting-edge scientific device known as the Scanning Habitable Environments, with Raman and luminescence for organics and chemicals, or SHERLOC. Under the findings of SHERLOC's investigation, the samples contain a group of organic molecules that have a spatial correlation with those of sulfate minerals. Sulfate minerals discovered in sedimentary rock layers can provide essential information regarding the wet environments in which they initially developed. Since 1976, when the 2 Viking landers conducted long-shot chemistry tests with unsatisfactory results, NASA has not explicitly looked for life on Mars. During its journey, the Perseverance rover collects soil and rock samples, which it will later place in tubes to be collected by subsequent missions carried out by NASA and the European Space Agency. Even while technology has advanced to the point where it is possible to construct compact, low-power scientific instruments for space missions, there are still many laboratory studies that cannot be performed in space or that cannot be completed with the same level of precision. In addition, the ability to repeat results is essential to the scientific method. Therefore, if we were to bring the samples collected by the Perseverance back to Earth, we would be able to conduct the same scientific studies in multiple laboratories. RIMFAX is a radar located in the rover's lower rear. It has the ability to identify pockets of water up to 10 meters below the surface. Scientists have a hunch that some of the the water that formerly existed on Mars made its way underground, where it may still be possible to support life. A meteorological station known as MEDA is also on board the Perseverance rover, along with a gadget dubbed MOXIE, which is about the size of a car battery and will remove carbon dioxide from Mars's atmosphere and create oxygen in the same way that a tree on Earth does. The MOXIE mission aims to prove that it can produce oxygen on Mars for future astronauts to breathe and utilize as fuel for rockets. In particular, the Mastcam Z, which consists of two color cameras that can zoom in and out and act as the rover's eyes, is an essential piece of equipment. The Planetary Society is a partner for the instrument in education and outreach. Within the belly of Perseverance was a miniature drone helicopter named Ingenuity. After arriving on Mars, the Perseverance spacecraft placed Ingenuity on the surface and then moved to a distance of 100 meters away. Since then, Ingenuity has been conducting repeated flights with the purpose of investigating the area around the rover. Although the success of the mission aboard the Perseverance is not dependent on the outcome of the technology demonstration performed by the Ingenuity, we are gaining valuable insight into the viability of flying vehicles on worlds other than our own. Titan, the biggest moon of Saturn, will be investigated by the Dragonfly spacecraft of NASA in 2034. This drone-like craft has 8 blades and is called a quadcopter. Scientists and mission operators collaborate to direct the Perseverance rover to potentially fruitful scientific regions by utilizing images from navigation cameras strategically placed around the rover and imagery from orbiting satellites such as NASA's Mars Reconnaissance Orbiter. 2 Raman spectrometers, scientific instruments that flash ultraviolet light on a rock or soil patch and read the reflected light signature to determine what chemical compounds are present, are at the core of the life-scanning tools carried aboard the Perseverance. Detecting organic substances related to life as we know it is a task that lends itself particularly well to using Raman spectrometers. The SuperCam is another instrument the rover boasts. This camera at the top of the rover's mast has a laser to zap rocks several meters away. The Pixel camera, which is mounted to the robotic arm of the Perseverance, will be used in the search for traces of little life. This camera can discern characteristics as small as a grain of salt. On the Earth, we have discovered fossils of bacteria less than a micron in size and rocks over 3.5 billion years old. When Perseverance scored its first rock sample in September 2021, the campaign for the NASA ESA Mars Sample Return got underway. The rover has also garnered 2 witness tubes, 1 air sample, and rock core samples. These are all kept inside the rover's belly. The rover crew is considering depositing certain tubes near the Delta base in about 2 months due to the geologic diversity of the samples already carried in the rover. The rover will continue its Delta investigations after dumping the cache. Without the help of additional scientific instruments, none of the discoveries made by the Perseverance rover would make any sense. Well, this brings us to the end of this video. If you liked the video, please consider subscribing and sharing so we can keep bringing you more content like this. Also, let us know your thoughts in the comments below, and we'll see you next time.